You know, whenever you run a Java application, have you ever stopped to think about what's really going on under the hood? It turns out there's this incredibly powerful, super sophisticated engine working away, constantly tuning and optimizing your code on the fly. So let's dive into what that engine actually is, the Hotspot Java virtual machine. And really, it all boils down to this one fascinating question. I mean, we all know Java's famous promise, right? Write once, run anywhere. But here's the kicker. How does it also manage to get faster the longer it runs? It almost sounds impossible. Well, that's the big mystery we're going to unpack today.
Okay, so the secret sauce here starts with something called the Java Virtual Machine, or JVM for short. The easiest way to think about it, it's like a universal translator. It's basically a machine living inside your actual machine. It takes your Java code, which has been compiled into this intermediate thing called bytecode, and translates it so it can run on literally any device. A Windows PC, a Mac, some server in the cloud, doesn't matter. And that is the foundation of Java's incredible portability. Now, you should know there are a few different JVMs out there, but today we're focusing on the king, the big one, Hotspot. This is the main event. It's the official reference implementation, it's the engine you'll find inside both OpenJDK and the Oracle JDK, and honestly, it is legendary for one thing above all else. Its absolutely relentless pursuit of performance.
All right, so let's follow the journey of your code, shall we? From the moment it enters the Hotspot JVM. The very first step, where it all begins, is a process called interpretation. Okay, so when your application first fires up, every single line of that bytecode is handled by something called the interpreter. The car analogy here is perfect. Think of it like starting your car in first gear. It's absolutely necessary, right? It gets you moving, it's super reliable, it just works. But you wouldn't drive down the highway in first gear, would you? Of course not. It's just not built for speed.
And that is where things get really interesting. This is where the JVM's built-in accelerator kicks in. It's this brilliant piece of tech called the just-in-time compiler, or JIT for short.
See, the JVM is constantly watching your code as it runs. It's paying attention, seeing which methods, which bits of code are being called over and over and over again. And for that specific code, the parts doing all the heavy lifting, the JVM basically says, okay, that's enough of first gear. It's time to hit the accelerator.
And that right there brings us to the name of the engine itself, Hotspot. A hotspot is literally just a section of your code, could be a method, could be a loop, that gets run a whole lot. And here is the really clever part. The JIT compiler doesn't waste its energy trying to optimize everything. No way. It focuses all of its incredible power only on these hotspots because that's where you're going to see the biggest performance boost. It's super smart.
Now, this whole optimization thing isn't just a one-and-done deal. Hotspot uses this brilliant strategy called tiered compilation. Think of it like an automatic transmission. First, you have the C1 compiler. It jumps in and does some quick, basic optimizations to get things moving fast. But if a piece of code gets even hotter, then the C2 compiler takes over. This one is the powerhouse. It performs these really deep, aggressive optimizations to get you maximum speed for the long run. It's a fantastic trade-off, right? C1 gets you a fast startup, and C2 makes sure you hit top speed later on. But look, pure speed isn't the whole story. A high-performance engine also has to be efficient, right? It needs to manage its resources well. And that brings us to Hotspot's second secret weapon, its automatic memory management system. You probably know it by its more common name, the garbage collector.
The entire strategy, the whole philosophy behind modern garbage collection is built on this one really simple but incredibly powerful observation. When you look at a typical application, the vast majority of objects that get created are only used for a super short period of time, and then they're not needed anymore. They're just temporary.
This idea was so fundamental that it got its own fancy name, the weak generational hypothesis. But don't let the name intimidate you. All it's saying is this. If we assume most objects die young, then the garbage collector can be way more efficient by just focusing its energy on cleaning up those new, short-lived objects. It's a classic case of working smarter, not harder.
And you can see that strategy right here in how the memory is organized. The JVM's memory, which we call the heap, is split into these two main areas. On the left, you've got the young generation. This is where every single new object is born. The garbage collector hits this area often and cleans it up super fast. Now, the very few objects that survive all that cleaning, they get promoted to the old generation over on the right. That area gets cleaned way less often.
This simple division is the core idea, even though newer garbage collectors like G1 or ZGC have even more advanced tricks up their sleeves. So, let's put it all together. When you take these two incredible systems, the super smart JIT compiler and the hyper-efficient garbage collector, what you get is a true performance powerhouse.
It really is the perfect partnership, isn't it? You've got the JIT compiler acting like the engine's turbocharger, constantly making your code faster. And then you have the garbage collector, which is like this automated self-cleaning system that makes sure everything keeps running smoothly and doesn't get clogged up with junk.
And this is the answer to that question we asked at the very beginning. The reason your long-running Java application actually gets faster over time? That's the JIT compiler working its magic on those hotspots. And the reason it stays so stable? That's the garbage collector, efficiently managing memory behind the scenes. And the best part, this incredible teamwork, this synergy, it all happens automatically, deep inside the hotspot JVM without you ever having to lift a finger.
It kind of makes you wonder, right? We have this engine that literally gets smarter the longer it runs and cleans up after itself. So if our software's engine can already optimize and maintain itself automatically, what's next? What's the future of performance engineering when the machine is already this intelligent? That's something to think about.